Welcome, everyone, to today's explainer. For this session, I want you to go ahead and imagine me as your Ustad, your master electrician, and you are my dedicated apprentices. We're going to be looking really closely at the Directorate General of Training's official electrician manual. Specifically, we're digging into the expertly crafted Bengali language edition of Module 2. Our main goal today is to build up those foundational, hands-on electrical skills. These are the fundamental building blocks of the trade. They're literally the only thing standing between a perfectly safe electrical system and a really dangerous failure. So grab your mental tool belts and let's get to work. Okay, let's dive straight into our roadmap for today. We're going to progress through 5 distinct stages: wire preparation, wire joints, soldering, underground cables, and we'll wrap it all up with fault detection. Starting off with Section 1, wire preparation, or as it's called in Bengali, tar prostutkoran. Now, you absolutely cannot make a safe, reliable connection if your wire isn't prepped correctly first. There are 3 fundamental micro steps to wire preparation. First up is skinning, which is just stripping the insulation. Now, listen closely to your Ostad here. The golden rule is to strip that insulation without ever nicking or scratching the inner copper core. Even a tiny nick creates a weak point where the wire can snap later on. So after safely skinning the wire, you'll neatly twist the strands together so they act as one solid conductor. And finally, you crimp the ends to guarantee a totally secure fit into your terminals. But hold on, before we even think about cutting or crimping, we have to measure. The manual heavily highlights using a standard wire gauge, or SWG, along with micrometers. So why does all this precision matter so much? Well, knowing the exact size of your conductor is really the only way to ensure you're selecting the proper tools, the right lugs, and the correct connectors. Guesswork has absolutely no place in a professional electrician's toolkit. Moving right along to Section 2, various wire joints. Bibhinno tarar joint. Once our wires are perfectly prepped and measured, we transition to actually connecting them. Now, this is the core syllabus of your Module 2 practicals. These are the essential joints every single electrician has to master. We've got the simple twist, the married joint, the T-joint, which is great for branching off a main line, the Western Union for extending your length, the Britannia for overhead lines, and the classic rat-tail joint. I assure you, committing the physical techniques of these specific joints to muscle memory is exactly what separates an amateur from a true professional. And here is the big why behind all this joint-making practice. A good joint provides massive mechanical strength before it ever sees a single drop of solder. The physical connection just has to be completely mechanically secure on its own. If those wires can wiggle or pull apart easily, you're going to get loose faults, arcing, and potentially a very dangerous fire later on. That initial twisting and weaving of the copper, that is your foundation. Which brings us to Section 3, soldering techniques. Soldering a Korshel. Now, what's really interesting about soldering is that this is how we permanently seal those joints we just painstakingly twisted together. Let's define it clearly. Soldering is the process of joining electrical conductors using a melted metal alloy, which we call solder, along with a chemical cleaning agent called flux. The flux is absolutely crucial. It actively cleans the copper of oxidation as it heats up, and that allows the melted solder to flow seamlessly into every microscopic gap of your joint. Let's walk through the exact steps for this task. First, you clean the joint perfectly. Second, apply your flux evenly across the bare metal. Third, apply heat and carefully feed your solder until it melts and flows completely through the twists. And finally, and please take this serious safety warning from your rentor, let it cool naturally. Do not flick the hot solder to get rid of the excess, and whatever you do, don't blow on it to speed up the cooling. Blowing on it can actually cause a cold solder joint, which makes the connection brittle and weak. Patience is key here. All right, Section 4, underground cables. Bhugarbhasto tar. Now that we've mastered the micro skills of skinning, jointing, and soldering, let's shift out to the macro stage. Underground, or UG cables, are a completely different beast on the outside, even if the electricity flowing on the inside is exactly the same. These are heavily insulated, steel-armored cables designed to be buried directly in the earth. Because they live in such a harsh, wet environment, they demand much tougher dressing, really intricate skinning processes, and heavy-duty sealing techniques to keep the moisture completely out. The sheer complexity of prepping a straight joint for one of these cables is incredible. You aren't just stripping off a bit of plastic anymore. You are dealing with brass glands, you're carefully stripping back a lead sheath, and precisely removing exactly 150 millimeters of paper insulation without causing any damage to the cores inside. It requires immense, heavy-handed precision. Once the internal wires are finally joined and soldered, the entire assembly has to be sealed inside a heavy cast iron or resin box. The manual strictly instructs us to use plumbed solder and to pour the hot bituminous sealing compound very, very slowly until the box is completely full. And just like with our small wire joints, you have to wait for this massive joint to cool perfectly before it can ever be buried. And finally, Section 5, Detecting Faults. Talar Truti Synoctocorin. But what happens when things go wrong? Because even the absolute best underground cables can get damaged by construction digging or just slow moisture ingress over the years. You obviously can't just dig up miles of earth to find one broken wire. Instead, we use sophisticated diagnostic tools, things like the Megger insulation tester and the Wheatstone bridge setup. These tools allow us to shoot electrical currents down the line to pinpoint invisible faults buried deep in the ground. Let's go over the standard loop testing procedure. Step 1, and this is by far the most critical, always ensure the main power is completely off. Then you connect the Megger terminals to your cables. First, you test for open circuits. That's where the wire is completely broken, which gives you an infinity resistance reading. Then you test for short circuits. That's where wires are accidentally touching, giving you a 0 reading. Honestly, finding the exact location of the fault using these mathematical tests is just as important as knowing how to physically fix it. So, as we wrap up this explainer, I want to leave you with a bit of a challenge, my apprentices. Whether you're just twisting up a simple rat tail joint for a light bulb, or you're pouring hot compound into a massive underground high-voltage splice, I want you to ask yourself, are your connections safe enough to withstand the test of time? Because at the end of the day, an electrician's true legacy isn't just making the lights turn on today. It's the unwavering safety and the durability of their work for decades to come. Thank you so much for learning with me today. Keep practicing those skills, and I'll see you in the next explainer.